Welcome. This is class number 33, lecture number 33 of part 1. We are coming to the closing part of the coplanar force system, parallel force system heading. Not long back in the introduction earlier, I told about this parallel force system, but still briefly. A parallel force system is a theory I wrote earlier because why should I, if I write in front of you, time waste. A parallel force system is one in which lines of action of all the forces are parallel to each other. All the forces, lines of actions should be parallel to each other. Simple language, everybody knows it. Next, there are two types of parallel force system, namely, one, like parallel force system, and two, unlike parallel force system. Like parallel force system is one in which lines of action of all the forces are parallel to each other. See, the moment you tell parallel means this is compulsory. Remember, make a note here. Like, you should make a small note here. I won't tell once again. Whether it is like parallel force system or unlike parallel force system, lines of action should be parallel. That is compulsory. Both are parallel only. So, like parallel force system is one in which lines of action of all forces are parallel to each other. This is the condition for parallel forces. Now for like means, and also direction of all forces are same. See, one force this way, second force same way. See, first of all, like parallel forces, you make a note. Two conditions. Condition one, parallel. Next, like means same direction. See, vertically down, vertically down, vertically down, vertically down. Or up, or right, or inclined, but same inclination. Understood? These are all like parallel forces. Unlike parallel force system is one in which lines of action of all forces are parallel, that is compulsory each other, but direction of all forces are not same. Now, something I will tell, you have to add it. Direction not same means not one force this way and one force this way, not that way. See, make a note here, class. First of all forces should be parallel. If one of them is down, other can be up, because down and up, see, both are parallel. But you cannot have one down and one inclined. Then it is a coplanar force system. So make a note. First of all, see there, you write parallel, see only lines. Parallel. But see, down, up, down. Right, left. Don't by heart this way, and this way. So make a note here. Direction not same means not random. Direction of, you should make a note here. Direction of some of the forces will be opposite to direction of other forces. If some forces are vertically up, others should be vertically down. All this you are right. If some forces are horizontally right, some other can be horizontally left. If some are inclined this way, some other forces should be same angle, parallel, but opposite. Make a note. Now I will go for how to find resultant for parallel force system. Very simple. Now come to resultant for a parallel force system. Make a note. It is same as that for, we are considering only coplanar. Remember, we are considering coplanar parallel force system. So, resultant for a parallel force system can be either a resultant force or a resultant couple. Same as coplanar force system. Now, something I will tell here, class, write everything. Little earlier, we considered coplanar force system, where I told resultant can be either in the form of a force or in the form of a couple. Always first you find resultant force. If the resultant force exists, that's all. Resultant is in the form of a force. But in case resultant force vanishes, never blindly tell resultant is zero, then it is possible that resultant maybe resultant can be in the form of a couple. But in case later, if the resultant couple also becomes zero, system is in equilibrium. So write everything. Now, if the resultant is in the form of a force, then resultant force is said to be completely defined if we find same as earlier, magnitude, direction and line of action of resultant force. Whereas if the resultant is in the form of a couple, then the resultant couple is said to be completely defined if we find magnitude and direction. There is no line of action for couple. Okay. Now, note, in case of like parallel force system, the resultant will be always in the form of a force, 100%. Like parallel forces system, resultant can never reduce to a couple. It is 100% in the form of a force. Why, you see later. But whereas in case of unlike parallel force system, there both chances are there. In case of unlike parallel force system, the resultant can be either in the form of a force or can be, see, here guaranteed in the form of a force. Here it can be either in the form of a force or it can be in the form of a couple. This is for unlike parallel force system. Okay, now, as I told you, if it is a resultant is a force, you have to find what? Magnitude, direction and line of action. If it is a couple, magnitude and direction. Now, I will go for calculation of resultant force for parallel force system. First, today I will take up a case of a like parallel force system, systematically solve it, get the answer, then we will extend for unlike parallel force system. Start now systematically. Question 1. See, procedure I am dictating in the class. And for your information, actually, for finding resultant for a like parallel force system, some extra theory is there. In the books all you can see, like resultant equal to sigma P1 plus P2 plus P3 plus P4 etc. And distance of line of action of resultant, some people call x bar or y bar equal to P1 x1, P2 x2, P3 x etc. divided by P1 plus P2 plus P3 or resultant or y bar. Those things all, it is required for when you go for center of gravity etc. later you require it. Or when a parallel force system, moving load system, all loads are downward, there you require. All those theory, here I will not cover. Here I am covering basic concept. So those things, in the notes I will write everything. And also, for the procedure, like earlier, in the class I will dictate the procedure. Correctly, you have to, those who are depending on only on class, you have to write simultaneously somewhere procedure. That is right here, procedure to find resultant. Today I will tell procedure for this one. Next time I will tell procedure continued. In the notes, not that way. I will give general procedure applicable for any case. That is systematically. This is also systematically, but I am not writing it in the board. Okay, start. First, question 1. Find the resultant for the given parallel force system as usual completely. Completely. Okay, correctly see. Right here. First, this I am telling so many times. Completely means magnitude. You should write, those who are serious. Same question when I solve in the notes, I will write it. Magnitude, direction and line of action. Okay. 4 systems given here. Okay. See, first make a note here. Procedure for finding resultant for parallel force system, whether like or unlike anything, general procedure. First check, is it a parallel force system? Yes, it is a parallel force system. See, in between what I will do is, I will solve an extra question deliberately. See, this way. This is not a parallel force system because see, this force is not in the same, it's not a parallel. So this will once again go back to coplanar force system. I will write and briefly solve. Then I will tell. Coplanar force system, you know how to solve. So solve it. I will give answer. Then here see, resolutions required. Now, second note, procedure. Resolution. See, if all forces are given vertical, either up or down, no resolution, everything is vertical, over. If or along y-axis, if all forces are given horizontal, again no resolution, yes, okay. But remember, if the parallel force system given is like this, but remember, parallel, like or unlike does not matter. Then, do you require resolution? If it is a coplanar force system, if inclined force comes, you require resolution. You should write, in the procedure you have to write it. In the notes I will write big letters. No. In parallel force system, even if the forces are, even if it is all are inclined forces, but one thing, parallel to each other, then resolution is not required. Why? I will tell you when I solve the question. You write that in the procedure sheet. Why? He told he will solve when he takes that question. Right now, okay. Leave it now. Now, make a note. Before you start solving, make a note. Given force system is a parallel force system. You should write. See, you should write now. See, I write here. Solution. I write here. Solution. Right here. Solution. What all I dictate, you write now. Given force system is a parallel force system. First, neatly sketch the force system. See here. Don't worry about that A. Don't see that A. Do not see that AB. 250, 275, 350, 300, 125. They are given distances odd way. It is better to write always cut distances. See, 0.7 meter, how means given. 0.7 meter. So this is clear. Then 0.8 meter, clear. This is 1.8 meter. This is 0.8 meter. So this will be 1 meter. See, 1 meter. How means I can't answer. Now, 0.7, 1 and 1.8. 1.7 plus 0.8. 1.7 plus 0.8 is 2.5. Total length 3 given. So this gap will be 0.5 meter. So these are all, see, this is given, this is given. These two are calculated. Remember, these two are calculated. Usually what I do, if it is a calculated, I round off. Rounded means calculated. Now do one thing, this can be thrown outside. I want more space. I can happily remove that one now. It is not required. This I don't require now. Check the answer. 250, 275, 350, 300 down, 125. Okay, now I don't require. Now, first, all forces are in vertical direction or along y-axis. Therefore, no resolution. Resultant also will be vertical. So directly calculate. Let R be magnitude of resultant force. Now, find R equal to, actually I will tell you, some forces are down, some forces are up. My first question, I am taking unlike, not like. I see. my first question, I am taking unlike. Tell why? Reason because you learn the difficult one first. Once I explain clearly the unlike parallel force system, like I can solve very easily, you will agree very easily. You should see the time also, not keep on prolonging the class. So, but in the notes, first question will be like only. Okay, now, some are down, see, some are up. Actually, if you observe 250, 350, 300, these three together are 850, I think, correct? 900, correct. These three together are 900. And 275 and 125 together are 400. 900 down, 400 up means 100% resultant is down. So by observing the sketch, you can tell resultant is down. Correct. That is what you should do. Therefore, you write resultant force are downward direction, you can write. But first question, I don't go for logic. Someone will ask, see the resultant, see some are down and up, more are down. You tell I am not seeing it, I am not seeing it. Let R be the magnitude of the resultant force, R, I will take upward positive. Why? All these days I am taking upward positive, today upward positive. Somebody may tell me, you see correctly there, more and more forces and heavy forces are downward. If you see the problem, you can make out very easily, downward is more. I will tell I am not seeing it. Who are you to tell me to see the problem? I am not seeing it. I will take upward positive equal to minus 250 plus 275 minus 350 minus 300 plus 125. Oh, answer came minus 500. Class, we found the resultant magnitude assuming the direction to be up. But the negative sign came, therefore the real resultant is actually in a direction opposite to the assumed direction. So after writing all the statement, resultant, therefore resultant force R equal to, no minus sign now, 500 Newton down over. Note, class, magnitude over, direction also over. There is no alpha etc. is not there. Magnitude over, direction over. Okay, both are over. Now to locate line of action of resultant. Okay, 1 minute. You write. But actually, if somebody will ask me to find the resultant, I will not take upward positive. If you got courage, what you can do? I will see here. By looking only I can make out. Resultant is 100% down. So what I will do? I will calculate R in downward direction. Then what I will write? I will write plus 250 minus 275 plus 350 plus 300 minus 125. I will get plus 500. Oh, therefore, correct. Resultant R equal to 500 Newton down. Yes, correct. See, you make a note. You don't write, we can understand easily and directly take resultant to be down, but sir took upward because he has got confusion. No, I have no confusion. I am taking care of all the people, even the weakest people. Though some will tell, sir, earlier you took upward positive, sir, now you took downward positive. Okay, done. I will take downward positive. So what? Those who are intelligent and know much better, you can apply your principles. Don't think that I do not know those things. Okay, now, to locate line of action of resultant. See, now, see, first make a note. See, in the notes I will write all these. When resultant is purely vertical, to locate line of action, you require horizontal distance. I told so many times earlier. When the resultant is vertical, you require horizontal distance to locate. Or when the resultant is horizontal, you require vertical distance to locate it. Our resultant is vertical. So to locate the line of action of resultant, you require horizontal distance from any reference point. In coplanar force system, you took a reference point. In a parallel force system, you take a reference axis. Usually, see, horizontal, again, see, you are engineers. Horizontal distance is always from a vertical reference axis. See, any horizontal distance is always from a vertical reference axis. Any vertical distance is always from a horizontal reference axis. That much common sense should be there. See, where I am height-wise, vertically, is from horizontal floor. Where I am standing this way, horizontally, is from a vertical floor, vertical wall. Therefore, make note, when, see, you can make out, when there is a vertical force is there, you require horizontal distance. Okay, note, all this one you write. Now, on the reference axis you have to take. Usually, right, reference axis is taken through the first force. See, merging with the first force. Here, see, I write here now. Consider, this is a color difference now. See, new color. Consider vertical reference axis AB as shown. This is as shown to locate line of action of resultant force R. Okay. Next, let line of action of resultant R be at a distance of x. See, x from reference axis AB. From reference axis AB as shown. Do one thing. Show, see, somewhere here, show the reference axis. See, same reference axis AB. This is AB, outside right, AB, same AB. Resultant is somewhere here. We don't know where. We already know resultant R equal to, we know the answer, how much? 500 Newton. Direction down. This distance is x. From here to there is x. Now, you show that sketch. To get x. Over question. To get x. Apply Varignon's theorem. Varignon's theorem. Consider moment about any point in AB. Moment about any point in AB. Say this point. Right here. Any point in AB. You can take here also. See, wherever you take, distance is same. AB. Then, any point about AB. Then, see, about moment about AB line you are taking. Then, right here. Any point, say, moment about any point in AB, say some name, A dash, okay, A dash. Then, algebraic sum of, only once I am writing, actually I should not write, algebraic sum of moments of given force system about, you can tell either about AB or about A dash. Okay, A dash is better. Equal to moment of resultant force about the same point or same axis A dash. Same point A dash. We will take clockwise positive. Moments are in Newton and meter. Our units are forces in Newton, distance in meter. Take, start. Come here. See, at any point is here, somewhere here. Okay. Start. 250. See, left hand side. See, right here, for left hand side, see the given force system. Left hand side, I suddenly felt little jerk like that. Okay. Sometimes it happens. For left hand side, see the given force system. For right hand side, see this sketch. Okay, start here. Oh. Moment what is fine. 250 into 0. Why 0? I will not tell. I won't waste time. Into 0. 275 into 0.7. It is anti-clockwise. Minus 275 into 0.7. Plus 350 into 0.7 plus 0.5 is 1.2. Plus 350 into 1.2. See, why I should not tell. 350 into 1.2, you have to write how you got it. Engineering students or engineers, 350 into 0.5 plus 0.1, plus 300 into 0.7 plus 0.5, 1.2 plus another one, 2.2. If someone will tell, sir, distance is not clear, means I will tell, you better not study this subject. Lastly, minus, anti-clockwise, 125 into, this is 2.2 plus another 0.8, that is 3. Actually, it is a given distance. See, in the question only, this is given 3. Minus 125 into 3. This is algebraic sum of moment of the given force system about any point here, A dash. See, mark here. Okay, mark that A dash. Actually, A dash is not required. Equal to resultant R. See here. Resultant R multiplied by your X. Your X. And very important, R is 500 Newton. And R into X is clockwise. That is equally important. Clockwise over. Therefore, solving, you get the value of X. Now I will get the value of X and meter. It will come in meter. Solving, you get the value of X. 1 minute now. I do not want to waste time now because some tricks are there, I will tell you. Not tricks actually, some extra concepts are there. I will calculate first. I got the value of X as plus, very important, make a note. Always write the answer with sign. Otherwise, danger, especially for unlike parallel force system. Danger. I got right there, everything you are right, plus 1.025 meter. Now, some note you are right. This I am telling thousands of times earlier. We consider line of action of resultant from the AB axis or from the reference point here to right side by X. See the arrow mark here? We consider to right side by X. And we got positive, means correct. The line of action of resultant is at 1.0, no plus now, 1.025 meter to right of A. Therefore, I will do one thing now. I will represent the resultant systematically somewhere here. See, now these all not required. Not required. Therefore, I write here, no space there. Lastly, therefore, resultant, red color. Why? Resultant is red color always. I am sticking to same format. Therefore, resultant force, now it is a force for given parallel resultant force, say you write here R for given parallel force system is as shown below. As shown below, right, where magnitude, direction and line of action all are clearly marked. You are right. Magnitude, direction and line of action all are clearly marked. For that, do one thing. Write a small sketch. See, 250 Newton here. Write it once again, no problem. 250 Newton. After 0.7, little down, okay. Here. 250 Newton here. After 0.7 meter, 275 Newton. After further 0.5 meter, a downward force of 350 Newton. This much is not required. This is to correctly give idea. A further, how much? 1 meter, 300 Newton. And further 0.8 meter, 125 Newton. Somewhat to scale. Right here, distances also, right? How much? 0.7 meter, 0.5 meter, 1 meter, little out of scale, little bigger it should be, okay. 0.8 meter. See, from our reference axis AB, what we consider reference axis AB, where is it? I'm not getting the color. Okay. Our reference axis is taken here. From here to right side by 1.025. This is 0.7. Okay, 275. Let come let this side. Okay, 275. Come here. 275 Newton. I took from here to right side by 1.025. See, 0.7. From here to here is 0.7 plus 0.5 is 1.2. So it is after 275 but before 350, or you can tell it is 1.025. It is closer to this one. See. This is the resultant force equal to 500 Newton. It's a big sketch required. Space problem is not, okay, leave it. You write bigger. From here to here is now no arrow mark. 1.025 meter. If you want, then from here to here it will be from total 3, subtract that 1.025. You should make a note. From total 3, subtract that 1.025. 3 minus 1.025 is 1. Resultant R is giving trouble. Okay, I write here. Resultant R is, I told the statement, okay, 500 Newton, 1.975 meter. This is actually, I write a big sketch actually. Today's space problem is there. You write a bigger 1 meter. You see the camera, how big it is. Okay, reasonably okay, I think. Okay, reasonably okay. You write bigger. What I tell you should follow. This is the resultant for complete force system. This I'll remove now. This is the final answer. See? Box. Now make a note. Nobody in the world can change this answer. Nobody in the world can change this answer. 1 minute. Again, doubt about the camera. Yes, no. Okay, right. Now, question is completely over. Now what we will do is, we will do some curiosity. Curiosity means extra. Actually, question right here. Question is completely solved. Over. But to understand the basic concept, see what I will do. See what I will do now. See correctly. You should write all those things. Everything you have to write. To understand the basic, let us do some research. See, research or curiosity. He took resultant from this point. What will happen if I locate resultant from other side? See now. Now, see, after getting resultant magnitude, that is same. R equal to 500 Newton down to locate, same sentence, to locate line of action of resultant R, we considered reference axis AB, we consider reference axis AB what? Through first force on left side, that is through 250 Newton. Now, let us see what happens if we locate resultant from right end force, that is 125 Newton. That is okay. Now what you consider reference axis, okay, not AB, say CD as shown through that force. Okay, right, once again sketch here. 250 Newton, 275 Newton, 350 Newton, scale is not maintained, 300 Newton and 125 Newton. Suppose I take reference axis here, CD. Any point I take here, say C dash. Then distances. How much? 0.7 meter, 0.5 meter, 1 meter, 0.8 meter. Then let line of action of resultant be at what it x only, x from CD as shown. See, same CD, a point C dash here. We don't know where, don't see there, blindly. Now see, now you take x to left of C. Be careful. Now you are considering x from CD line to left side. Very, very important. You write here now. Now our distance x is from CD to left of CD by x. Okay. Now I won't waste time. Apply Verigno's theorem. You write moment about the C dash point. Moment about C dash. Story you write yourself. Algebraic sum of moment, etc. Take clockwise positive. Newton meter. You write. Start. Moment here. 250 into 3. See, moment about this point. It is anti-clockwise. Minus 250 into 3. Plus 275 into 0.8 plus 1, 1.8 plus 0.5 is 2.3. Minus 350 into 1.8. 1.8. Minus 300 into 0.8. Lastly, plus 125 into 0 equal to, very careful, 5 resultant R into x. But be careful, one small mistake will spoil everything. We are taking clockwise positive. R into x is anti-clockwise. Very, very important. Minus. Solve and get the value of x. I will not touch my calculator now. I will not touch the calculator. I will do one thing. Take the calculator and I will tell it, give me correct answer. It will come plus 1.975 meter. Plus only will come. Right now, some note you are right. We considered resultant from this force to line of action to left side. Yes, answer came plus. Plus is not left side, right side. Plus means how you considered is correct or not. Yes, we consider to left side plus. Therefore, line of action of resultant will be at 1.975 meter to left of this force. Or if I put a sketch here, from here to here is 0.8, this is 1.8 more, from here to here is 2.3, so little this side, 1.9, oh, same answer. That is 1.175, this is 1, oh, right here. Therefore, once again put this sketch. Okay, now see, further research, just for fun, let us locate resultant, locate what? Line of action of resultant R from a random axis A, B, C, D over some another axis called EF. Another axis EF. Which axis? EF. EF as shown. Okay, where? Somewhere here, outside. Right? We will consider EF outside. One point here, say E dash. One point outside. Somebody will ask, why? Just like that, just for fun. How much distance? Any random distance, whatever you want. This is our choice. This one, take any value, any distance. Okay, I will take, say, just to checking purpose, random number. But I can't take little bigger number. 200 meters. Very, very outside. So out of scale. See, then I have to put the point somewhere out of scale. 200 meter. Okay. Then resultant R also should be taken at X from EF only as shown. See. Anywhere you want. X. Okay. Apply Weringno's theorem about the point E dash. About this point. Start. Same story once again. Take moment. 250 into 200. 250 into 200 clockwise minus 275 into 200 plus another 0.7. So minus, how much it is? 275 into 200.7. 200.7. 200 plus 350 into, this is 0.5 plus 0.7 is how much? 1.2 plus 200. 201.2. 201.2 plus 300 into 0.7, 0.1, 0.2, 202.2. 202.2 minus 120. This is not there. That EF is not there now. Minus 125 into minus y anti-clockwise into, this is 3, this is 200, 203 equal to moment of resultant R into X equal to R into X. But remember, clockwise, R equal to 500 Newton. Get the value of X in meter. I will not use my calculator. I am so sure it will come 201.025 meter. 201.025 meter. Or just to check whether values what I wrote here is correct or not. Because if I made any mistake in distances here, tomorrow somebody will comment, it won't come. Checking is not for concept. I will not stop this class till I get this answer. 250 into 200 minus 275 into 200 points. I can make out if any mistake is there. Plus 350 into 201.2 plus 300 into 202.2 minus 125 into 203 divided by 500. It is giving some calculator error. 250 into 200. I don't know what happened there. Minus 275 into 200.7 plus 350 into 201.2 plus 300 into 202.2 minus 125 into 203 equal to divided by 500. 201.025. I got it. I checked the value not because I was afraid. I told it has to come. I checked only one reason. When I took moment about this point, in case by chance some distance is wrong, answer will not come. Now right here. Therefore, we consider resultant from EF as reference, random reference EF to right side by X. X came plus. So correct. It is to right side by 201.25. But our reference is, from reference, you have to go 200 meter to reach the first force. So from 201.25, subtract 200. So further you have to go by 201.025 minus 200 is 1.025 meter to right. So therefore now also after all the statement, resultant remains same. So now do one thing, those who are interested, you take a reference axis somewhere here and check. But do not take reference axis some in between also you can check. Okay, that next class, if possible, I will find distance from one of the point here. Okay, next class I will do. Time is already over now. Because too late in the night now. So therefore, if you or no leave it, in the notes I will write it. So those who are serious can do one thing, locate resultant from a point here, inside point, but not advisable. It is not advisable. Better locate with respect to either extreme end or outside point. From inside point locating not advisable. What happens, what mistake will come, in the notes I will write it. For general public, this is sufficient. Why general public? Notes means those people who want to learn more from me. So I will give more information for them. Okay. We'll meet in the next class now. Thank you.